spontaneous guest, I would say. I was been invited by making contact with Brand and others. I'm coming from Wuppertal University. I'm professor for building physics and technical services. And I was always watching what's going on in these dynamic testing in IA work before. And what you see on this slide is a settlement of experimental houses coming from the Solar Decathlon 21-22 taking place in Wuppertal, Germany. And some of you might know that this, this was a big field with about 20 houses, and 8 of them here are left on site for experimental purposes. Before we run this Solar Decathlon in Wuppertal, there was an IA Annex taking place, Annex 74, Competition and Living Lab platform. And the idea of this annex was to stimulate the Solar Decathlon, namely to allow to be a bit more closer to building science and not only to be a showcase. The background was that it's such an expensive event that you have to take any opportunity to make more out of it. And we developed certain ideas in this annex. I was the chairman of this annex. And some of them were applied in the competition in Wuppertal, and namely co-heating tests, inspired by the work of Annex 71 and others. Then you see equipment here, a fan heater, temperature sensing, things like that. And the teams have to perform, or let's say we automatically perform during the competition, the tests in the houses, and the teams have to run simulations, dynamic simulations with standardized tools. We give them a tool, we give them the on-site weather data, and they have to run simulations to find out if the performance simulated is close to what they measure, what we measure. And you see here, one example shows that roughly it's fine. It's not the case in that time that students get points for coming quite close to the measured results. It was more to educate a bit more students that simulation is not just fun and making it happen. It's also always to be critical and big question whether the outcome can be possible or is it nonsense. Yeah? And as I teach simulation also to students, I know that students like simulations, but they also like to produce nonsense. Because it's complicated. Very complicated. Okay, so after the competition, some of the teams go deeper into it. They use their own tools, or let's say more advanced tools like either ICE, Energy Plus, Ladybug environment, and they run the same test with that tools and see, okay, the tools give also results comparable to the simplified tool we gave. We have made some investigations on it and publications. And after this time of the competition, I mentioned we have 8 houses remaining. Some of them are suitable for more testing and research, some not, because of their building construction problems or technical problems or whatever. And you can check on the webpage what's available. You can also have a digital walkthrough in each building and see how it looks like. I will not do this now because it's time consuming, but you can look into every building by the digital twins. And what we have done then in the last year, after we have reinstalled the monitoring equipment, made some calibrations and so on, we have run new tests with unoccupied buildings. Buildings means these are housing units in the size of 60 to 100 square meter, fully equipped with kitchen, furniture, and everything. And during that time, they were not used. So no occupants in the buildings. This is an example with the outdoor temperature measured. Then this is the pointed line. This is simulated indoor temperature, and the red line is the measured indoor temperatures. And you see that we do some conditioning tests here. It was heated to 30 degrees, then it cools down. Then we have co-heating with input by fan heaters during night, cooling down, heating to 30 degrees, again, co-heating. So this is done with different houses and also seasonal. We have also checked the HTC estimation based on that measurements. Here is an analysis for different time periods. The calculated HTC would be something like 664 for that building. And here are the different results for different periods, depending on weather conditions and also depending on the history before the days which were taken for this testing. There is also dynamic testing of U value of the wall construction of this building, performed with suitable results, but questions in terms of accuracy, uncertainties, something what we had before. This year, we had a new season, or this winter, with co-heating tests. This is a building, a single zone building. Here, once again, co-heating, dynamic co-heating for every night, stimulation by a fan heater, co-heating to 20 degrees, free floating, co-heating again, free floating with windows closed. And you can see the difference in the performance, the difference in cooling down. And you can see this for another building, which is then a two-zone building. So with a heated zone in an unheated zone. This is the first floor unheated. This is the second floor conditioned. Co-heating test, cooling down with some input by solar. Then co-heating again, fully shaded. So we have different buildings there on site with different opportunities and different results. Okay, we also have done free floating tests for different buildings in cloudy periods, in sunny periods, and we see the different performance of the different houses. And practically, I can say this is not scientific news. Yeah, everybody knows about this, but the students might not. So our focus is education. And therefore, our agenda is for the next period, we have the chance to run this project until end of 26. We wanted to go for, in summer and in next winter, for occupied situations. And this is also always a bit tricky then to transfer the unoccupied case to the occupied case and to understand in simulation how to simulate the occupancy. This is a tricky part. And so we will have more sensors installed regarding presence and opening of windows and doors, which gives some input, but still, as you know, operating of shading and window open or close can be a big range of how open, how close, things like that. But it's important to make students aware of the difference between unoccupied and occupied situations and how hard it is to handle occupancy in simulation. We have seen in our tests and want to go deeper into that it's not news for you, I would say, but it's practically not the same if the heat input comes from the floor heating or the co-heating test or from air heating systems. So what exactly is the heat input? You take into account for the HTC analysis. We have also seen differences regarding temperature homogeneity in buildings. So stratification, if you have an air heating system, stratification is different from the floor heating system, which means you have to take care about what is the correct indoor air temperature. Can be lots of air temperatures in that zone, depending on height and other things. Also, the boundary conditions below and around the building might give some complexity. In our case, the buildings are not fully on the ground. So there is some air movement, more or less air movement below the buildings, and this has to be described in more detail. You want to make correct comparison to simulations. Also, the temperature environment around the building might create a bit differences to a weather station nearby, because it's maybe because the sun is shining on the facade, have some increase of air temperatures around, and how to take this into account. We have sensors in all buildings in different layers of the constructions. All these are timber wall constructions, so we can see also the dynamic response of the different layers. And practically, we want to check the suitability of different tools for education, from simple ones, single Zoom tools. There are many of them, but these are 2 examples. I know it quite well. With some limitations, of course, in terms of input. So they might not allow you to exactly give inputs corresponding to your test sequences. Because of the simplification, this allows more details than this one. And of course, the multi-zone programs like these, they allow you to exactly follow the schedules you have done in the tests. And the main issue of all this for us is the educational purpose. So we want to learn to teach students to become more critical to these powerful simulation environments. This is our main issue. And this might be suitable input for subtask 5. That's my feeling at the moment, but I'm just new in that group, and sorry for maybe telling you things which you all know. But this was just a start from my side to say, okay, this is on the floor. We are open to share data and to share experiences. So now we are not member of Annex 94. It's might be possible, depending on what the German Expo member is saying to all this. But if it is meaningful, we can proceed in discussing this with the German Expo members. But let's see what's your impression from this part of the audience. Thank you for following.
I think I can safely speak for us all when we say we're definitely interested in all of that, because they present some quite unique buildings as well. Definitely. Does anyone have any questions? Karsten, just one. Very quiet today on questions. That's what I like. Excellent. Okay, it's more or less 4 o'clock, so I think we're gonna close.